Bienvenidos, Ushamdid, and welcome University of Maryland Global Campus learners from the CMIT-456 Section 6380 course for the fall 2021 semester. This is the Cisco Networking Academy's CCNP Enterprise Advanced Routing and Services, or ENARSI, version 8 course curriculum. This is going to be the first of what will be 20 packet tracer tutorial and activity videos detailing each of the packet tracer videos that make up this course. In this video, we're focused on packet tracer activity 1.2.1, where we're going to be taking a look at DHCP for IPv4 and routing between VLANs, or as you might hear it more commonly referred to, Inter-VLAN routing. So let's dive in and take a look at the activity and topology that we're going to be working with. As you can see, we've got router 1 here, and obviously we've got some links that are down due to the red upside down triangles, and we've got some work that's going to be done over here on the left-hand side. We've got our addressing table on the right-hand side, VLAN and port assignments below that, and so let's go ahead and dive in. We're going to be configuring VLANs, trunks, DHCP server pools, and configure a router as a DHCP client. So router 1 is not only going to be our DHCP server, we're going to see what it looks like to configure router 1 as a DHCP client, which is something that you can do. And if you're using Verizon or Comcast as your internet service provider at your house, and you've got sort of a basic plan where you're not dealing with static IPs, DHCP is how that address that you get on that outside interface is being allocated. So the first thing we're going to do is we're going to configure the VLANs and the trunking. And so we're going to be doing all of this work here on switch number 2. So let's dive in to switch number 2. We're in user exec mode as indicated by the greater than sign. To get into privilege exec, we use the enable command, and then configure terminal to get into global config. So create VLANs on switch 2 and assign VLANs to appropriate ports. Names are case sensitive. So let's go ahead and do the VLAN creation first. So we've got VLAN 10, the name is going to be sales. We've got VLAN 20, the name is going to be production. We've got VLAN 30, and the name is going to be marketing. Going to make sure we spell these right. And then we've got VLAN 40, and the name is going to be HR. Now, we've created each of those VLANs. If we were to do a quick double take here and look at VLAN 10 is the name sales, VLAN 20 is production, 30 is marketing, and 40 is HR, everything looks good. Remember, in Packet Tracer, if you're uncertain, there's this little check results button right down here that you can click on, and then there's an assessment items tab, which will show you if there are things missing from your configuration. Now, when you're working on your project file in our CMIT course, that is not going to be available to you. Again, you're going to have to know what you're doing in the packet tracer activity. There is no check results there. So back to this activity. Let's assign VLANs to the appropriate ports. And that's one way to think of it. I like to think of it, it's a little easier for me to think of it as assigning ports to VLANs. Instead of assigning VLANs to ports, I like to think of it as, oh, we're putting the ports into the VLANs. To me, that makes a little bit more sense. And so let's make that happen. So let's get into interface range, right? Fast Ethernet 05 to 9, meaning any commands that I'm running right now are going to be run concurrently on Fast Ethernet 5, 05, 06, 07, 08, and 09, those 5 ports. So the first thing I'm going to do is we're going to say no shut just to make sure. And we're going to go ahead and say switch port mode access. Now it doesn't, I don't see it asking, or there it is, configure all non-trunk ports on switch 2 as static access ports, meaning Fast Ethernet 01 through 4, those will be trunk ports. Everything else will be a static access port. Now, I could do an interface range command for Fast Ethernet 05 to 24 and come in and say switch port mode access, but then I'd have to get out of that and get into a different range to do the VLAN, the switch port access VLAN command. So it's up to you as to how you would want to do that. I prefer doing it this way because you're going to have to go into each of these 4 individual ranges anyway, because they each range belongs to a different range or a different VLAN. So again, I could do interface range, fast Ethernet 05 to 24, switch port mode access, but then again, I'd have to get into interface range, fast Ethernet 05 to 09 in order to come in and complete the rest of the configuration. So switch port mode access, let's say switch port access VLAN 10. Now, that is all it's asking for here. However, I like to sort of tweak with the activities a little bit and tinker with the activities a little bit to show you some best practice recommendations. Why would we not want to have spanning tree port fast on our host-facing ports, right? Or on our server-facing ports, the PCs, the access points, the DHCP clients, things like that. So we'd like to have port fast on. We're going to skip the listening and the learning states. And then what other spanning tree command would I want to have on here? Well, BPDU guard enable. And this is a per port. I'm doing all of this for the port fast and BPDU guard on a per port basis. You can do it in global config. I'm doing it under the interface configuration stanza. So we say BPDU guard enable. And what does BPDU guard do? Well, if any of the ports on which BPDU guard is configured receive a BPDU, it does not have to be a superior BPDU. BPDU guard states any BPDU, bridge protocol data unit, that is received on a port where BPDU guard is enabled, that port is going to be not administratively shut down, but it's going to shut down. It's going to disable, right? And that port is not going to pass traffic. And this is to prevent someone from unplugging a PC and then plugging a switch in that maybe has a better priority value, trying to turn that switch into the root bridge. So BPDU guard, any BPDU that is received. That's it. Traffic is done on that port. That port is going to be disabled, right? Not administratively shut down, but it's going to be disabled. Now, there's another spanning tree command that we can put on here, and it is guard root. Now, you might be saying, well, wait a second. You just told me that BPDU guard is going to shut down irrespective of whether the BPDU is a superior BPDU to the one the switch is currently receiving that indicates the root bridge, right? So why would I put spanning tree guard root on here? And it's a simple concept, defense in depth, right? Maybe a junior SA turns BPDU guard off by mistake. Maybe making configuration changes, it gets removed by mistake. Now we've got spanning tree guard root in the background ready to kick in. And that's the command, spanning tree guard root. And that is another best practice on a host-facing port. I'm stressing host, but it could be a server, it could be your DHCP server, it could be DHCP clients that you're plugging in, access points, whatever the case may be. But again, it's defense in depth. So do we get points for all these things? It doesn't look like they're asking us to do that on any of these ports, but I'm doing it here anyway because that is what you would do. So let's take a look, do show run, at what we want our host-facing access ports to look like from a configuration perspective. And so there it is. We've got our VLAN that the port is a member of. We've got the switch port mode access, statically configuring it as an access port. We've got port fast on to skip the listening and learning states because it's not a switch. It doesn't need the listening and learning states, right? To go through that, it needs to transition to forwarding immediately because if it is a DHCP client, that 30 to 45 seconds it might end up waiting until it hits the forwarding state. DHCP may stop and you end up with your APIPA address, right? That 169.254. So you don't want that. We talked about guard root if a superior BPDU is received. And we talked about BPDU guard, which means any BPDU that gets received. The port's going to be disabled, right? All right, so that takes care of that first range of ports. So now let's do, and we'll move through a little bit quicker here, interface range fast Ethernet 010 to 14. And it's going to be much the same thing. Really, the only command that is going to be different here is the switch port mode access is going to be the switch port access, right? Because we're in a different VLAN. We're dealing or assigning these ports into a different VLAN. But I'm still going to come back and say spanning tree port fast. We're going to say spanning tree BPDU guard enable. And we're going to say spanning tree guard root. We're going to go into interface range fast Ethernet 015 to 19. And we're going to say switch port mode access. Switch port access, this is the only different command, is going to be VLAN 30, the marketing VLAN. Spanning tree port fast, spanning tree BPDU guard enable, and then spanning tree guard root. And then our final range of ports is interface range fast Ethernet 020 to 24. We're going to say spanning tree port fast. Well, actually, let's do switch port mode access first, and then we'll say switch port access VLAN 40. And then we'll say spanning tree. We did port fast, so BPDU guard, BPDU guard enable, and then spanning tree guard root, right? So we're feeling pretty good right now about how all of the non-trunk ports look. However, let's do this. Do show IP interface brief. Because we know what's going to happen to fast Ethernet 01 through 4. We can see on the diagram right there above, those are going to be the trunk ports. We know what to do with the access ports. We were told the range of access ports. But when I say show IP interface brief, you'll notice there's 2 ports which are not in use, that are not being used as access ports. They're not being used as trunk ports. They're just here. And so now that brings the question up, configure all non-trunk ports, which gig 01 and 02 are, as static access ports. So we're at 27% completion down here in the lower right-hand corner. Let's go ahead and let's do this. Let's see interface range, gigabit Ethernet 01 to 2. Let's see if we get points for this. So switch port mode access. Again, we're at 27%. So we didn't get any points for that. So it looks like that was not something they were looking for us to configure. Now, those ports aren't even being used for anything, so I'm just going to go ahead and say shut down. So we'll shut those ports down, and maybe we've got to circle back, but I don't think we're going to need to do that. So I think we're good on the switch side here. So let's say write mem. Save our config, show run, right? You can see everything looks really, really good here. And 16 through 19. So there is a range. There's another range here that I just realized. And why is that? That should have been, 0 through 19. I'm sorry, 15 through 19. I'm glad I took a look at this. Well, let's go back into those ports, and maybe that was my fault. Interface range fast Ethernet 015 to 19. All right, so switch port mode access, switch port access VLAN 30, spanning tree port fast, spanning tree BPDU guard enable, and spanning tree guard root. And now let's go ahead, save our config. And we're at 33%, so we picked up a significant amount of points for that. I'm glad that I did a last show run there. And now it looks much better. And so I feel that we're ready to move on here, right? So the switch looks good. So let's slide. Actually, yeah, that gives us room to slide down just a little bit here. All right, so configure switch 2 ports for static trunking, right? Now, it's not asking for Ether channel. It's simply asking for us to set these up as individual trunk ports. Now, realistically, we would do an Ether channel configuration here, right? Because we want to make sure that all of the available bandwidth is being used and that we don't have a scenario where we have certain links that are just kind of sitting there, not being used. But this activity is not focused on Ether channel. So we're going to go ahead and go with interface range fast Ethernet 01 to 4. Now, how do we configure a static trunk port? Where we're going to say switch port mode trunk. Now, If these were older 3560s, you might have to say, you might have to change the encapsulation with a switch port mode or switch port trunk encap .1q command. Remember, there were two types of trunking encapsulation initially in the switching world. It was Cisco's InterSwitch Link, or ISL, which was Cisco proprietary, which was not very popular. And then there was 802.1q, which is the industry standard. And what ended up happening is ISL has gone away. In fact, it was on the 3650s, not the 3560s, but the 3650s and the 3850s, where ISL, that's where I first noticed it no longer being an option. And the only option was 802.1q. And so you did not have to say switch port trunk encap .1q. Right? Because that's the only trunking encapsulation that's available, so that's what's going to be on. On older switches, it would sometimes make you type in switch port trunk encap, and you'd have to change it or statically code it to be .1q. So we're going to say switch port mode trunk, and that statically configures all four of those ports as trunk links. Now, you'll notice it says configure S2 ports for static trunking. What it doesn't tell you to do is to turn off DTP, a Cisco best practice. Switch port, no negotiate. Because before I run this command, and let's show you the command. So we're going to say show interface, fast Ethernet 01 switch port. Whoops, sorry. Do show, and let me just pull that back and type in the do here. So what happens here is you can see the administrative mode is trunk and the operational mode is trunk because I've already said switch port mode trunk. Prior to me running that command, the mode on the port, the operational mode would have been static access. The administrative mode would have been dynamic auto. Right? And that's a dynamic trunking protocol mode, dynamic auto. And you can see right down here, negotiation of trunking is on. Well, if we are statically hard coding those four ports to be trunk links, do we need negotiation? And the answer is no. So once you've statically configured your links as trunks, which I highly recommend, because if it's meant to be a trunk link, then statically configure it to be a trunk. Don't leave it up to chance. Deterministic things are really, really advantageous in the routing and switching world. You want to be able to easily determine what is the state of this port. What is that port supposed to be doing, right? So we say switch port mode trunk, and then we say switch port no negotiate. That turns off DTP. That turns off negotiation of trunking, which is very important, right? And again, I won't get into the conversation as to, well, if Cisco's best practice is to turn it off, then why do they have it on by default, right? The short answer is to make it easy to plug things together and to interconnect devices, right? However, if everything's dynamic auto, remember that dynamic auto and dynamic auto, that is not going to form a trunk link for you. That will roll back to a static access. That's the operational mode that you will end up with as an access port, right? So again, it's a great question, and it's an interesting one. If it's going to be an access port, because both sides are auto, then why don't they just turn it off by default? And the reason is maybe you've got a switch where it's hard-coded static access as a trunk, and then you plug it in. That would also make the other side a trunk if it's dynamic auto, right? So take a look at dynamic trunking protocol, something that was covered in depth in our EN Core CMIT-455 course. All right, so that is our trunk link configuration. Now, this is another consideration you might want to think about here is switch port trunk, and then what could we do? Well, we could allow certain VLANs. So I could say switch port trunk allow VLAN. Now, I could say all, but that's the default, right? All is the default. In fact, if I say all, let's say do show run. And I love doing this. So I just ran that command and we didn't get an error. Why is that command not on a single interface we have listed out here? Because I just ran that command concurrently on those four interfaces, yet where is switch port trunk allowed VLAN all? Exactly. It doesn't show up because it's the default. And that's usually a dead giveaway, and I'll caveat 99% of the time. If it's the default, you don't see it in the running config. And so that's why I wanted to show you that command. Now, another option here is you could pick a range, right? I could put VLAN IDs. And so let's go ahead and say 1, 10, 20, 30, and 40, because those are the only VLANs we've got configured, right? And so this is a good way to kind of tighten things down. So I could do something like this. Now, I'm going to, oops, and I just hit enter by mistake. So we're going to go ahead and do that, and we'll see how things play out. Maybe we've got to pull that off. But again, this is a good security hack to make sure that only VLANs that you know are in your environment are allowed to transit those trunk links, right? Now, it doesn't match on the other side. And so, again, I want to make sure that we don't blow this activity up here. So I'm going to pull that off just for right now, but that shows you what you could do. So our trunking ports are now configured. So we're going to come down here, and now we're going to configure R1 to route between VLANs. And if we take a look up here, you can see we're doing inter-VLAN routing using router on a stick. Now, there are multiple ways that we could do this. You could use a multi-layer switch, which is just a router with a whole bunch of ports that has a switch device nomenclature like a 3560 or a 3850 or a 9300, right? With a layer 3 image on the device that would allow it to do inter-VLAN routing, right? So that's another way to do it. A third way to do it, which is probably not the popular way to do it, would be if we wanted to dedicate, because right here we've got a single port that is going to be servicing all the VLAN traffic, 10, 20, 30, 40. And if we don't have a lot of interfaces available here on router 1, this might be a good option. If it's a multi-layer switch, the number of physical interfaces on the device is typically not a big issue. And so you could do something similar to this with a trunk link and then have VLANs on that multi-layer switch. And that is how you're doing your inter-VLAN routing. And then the third and final way would be to say that link is going to be for VLAN 10 only, and then that would be an access port. And this would only be dedicated, the port on the router would be dedicated to VLAN 10. And then we do that for VLAN 20. And we do that for VLAN 30. And we do that for VLAN 40. And hopefully you're starting to see why this option here might not be the smartest use of your resources from a router perspective, because routers typically do not come with 24 interfaces by default, right? If you're ordering, like a 2900 or something like that. And again, we'll talk about sort of a CCNA level. We're not talking about ASR routers, ASR 9000 and things like that. So we're talking about like a 2900 series router, right? Or a 4400 series router. You're not going to end up with tons of interfaces on that router, and those additional interfaces are not given away for free, right? Cisco's not in the business of giving things away for free. So you're going to be paying for those extra interfaces. And so your use case question here is, how much traffic am I going to be generating northbound that is going to be using this individual link right here? If I do router on a stick, will 1 gigabit a second work? Well, we're kind of throttled down here. We're using fast Ethernet interfaces. So in this scenario, this is the quickest link in the environment between switch 1 and the router, and it has the most bandwidth. I say quickest, it's got the most bandwidth. So again, you would have to decide what is your use case going to look like, right? And what is going to work best for you. But there's 3 ways that you can go about that inter-VLAN routing scenario. So we've popped that command off. Let's now pull up the router. So here is, excuse me, router 1. We're going to configure router 1 to route between the VLANs. Subinterface numbers should match the VLAN number. And that's not a requirement, right? That is a best practice. And if it's not in Cisco's best practice documentation, it should be, because it's insane to think that you would configure, if I go into privilege exec and then in the global config, that I would say interface gigabit Ethernet 0.86754, and that's going to be the subinterface for VLAN 10. That makes no sense. Could I do that? Absolutely. Right? I could definitely get away with this. However, that makes no sense to do that. It would be insane to do that. That is what you're going to do. Again, that is not required. That is not necessary to have that subinterface number match the VLAN that we're dealing with. Now, the encapsulation statement under the subinterface, that's a different conversation, which we're going to have right now. So I'm going to say interface gigabit Ethernet 00.10. I'm going to hit enter. Now, the mistake most learners make is they're going to want to come in right away and say, okay, IP address 172.31.10.1, 255.255.255.224. So we're doing a slash, excuse me, slash 27. And we need to make sure it's a slash 27 there. So there we go. 255, 255, 255, 224. And this is what most learners will come in and try to do right away on a subinterface, but you're going to be greeted with a message that tells you you're configuring IP routing on a LAN subinterface, and it's only allowed if it's already configured as part of an IEEE 802.10 or IEEE 802.1Q or ISL VLAN. Well, ISL is no more, right? So 802.1Q, because it's that VLAN tag that's going to allow the router physical interface to multiplex the traffic and ensure that traffic that came from VLAN 10 is dealt with by this subinterface. And the same for VLAN 20 traffic. That's going to come across what is going to be, from the switch's perspective, a trunk link. Because over here on gig 01 on switch 1, that is going to be a trunk link. I don't know if they've got us configuring that here. It might already be configured. We'll see, because you can see the interface is shut down. We're going to be bringing our side up. So we'll see what happens. So anyway, back to the subinterface. Our subinterface number matches the VLAN. Not required, but best practice. We try to put the IP address on there, but it tells us, hey, you can't do that to a subinterface, because before you do that, you need to tell me, network administrator, you need to tell me, the router, what 802.1Q tag am I looking for to have the traffic dealt with by this subinterface? Incap.1Q 10. Now, if this is the subinterface for VLAN 10 traffic, that has to match. The .1Q statement has to match, or the .1Q number has to match the VLAN number for which this interface is being configured. That is how that physical interface on the router multiplexes the traffic coming across what is going to be treated as a trunk link, where when traffic leaves switch 1 gig 01 and shows up on router 1, this is a trunk link from the switch perspective, meaning the traffic is tagged with the VLAN from which that traffic originated. So we have to say incap.1Q 10 first. And in the .1Q statement, the 10, the number, has to match the VLAN for which this interface is servicing traffic. Now I can come back and put the IP address on the interface. And again, you can always throw, a description on here, VLAN 10, subinterface traffic, right? Now, I'm not going to do descriptions all the way through, so let's go into interface gigabit 00.20. Let's say incap.1Q 20, because that is the 802.1Q tag that VLAN 20 traffic will have when it transits that trunk link between switch 1 and router 1. IP address 172.31.20.1, and that is a /28, so 255, 255, 255, 240. And interface gigabit Ethernet 00.30 incap.1Q 30 must match the VLAN number for which the interface is servicing traffic. And again, I can't stress that enough because you'll see, and I guarantee there's a test question somewhere, that they'll show you sub-interface numbers that don't match the VLAN .1Q statement. And then they'll say, why is this sub-interface not routing traffic? And one of the answers is going to be, oh, because the sub-interface number doesn't match the .1Q number. And that, again, doesn't matter. It doesn't matter. But the .1Q number that we use here, .1Q 30, 20, 10, 40, must match the VLAN for which that sub-interface is servicing traffic and routing traffic. All right, so IP address 172.31.40.1, and this is a /26, 255, 192. All right, so now we've got all of our sub-interfaces configured. However, the parent interface, and by parent interface, I mean Gigabit Ethernet 00, is currently shut down. So if the parent interface is shut down, all sub-interfaces, all child interfaces are shut down, right? And that's what you're seeing right now. Now, they don't say shut down, but they are because the parent is down. So let's bring the interfaces up. So let's exit out, interface Gigabit Ethernet 00, and we can use extra zeros there, it doesn't matter. So interface Gigabit Ethernet 00, and I'm going to say no shut. And that's going to bring, as you can see right there, it brings up every single sub interface except for 40. And did I do 40? I thought I did 40 here. I apologize. Interface Gigabit Ethernet 00. And so again, fortuitous failure, right? Because this is going to show you that, and you can see it brings it up immediately, is that I don't have to bring the main interface down and then back up again. It's once that main interface is up, the parent interface gig 00, all sub interfaces are going to be up. Now, can you come into a sub interface and shut only that sub interface down? Absolutely. And I'll show you how to do that here in a second. But first, let's deal with this. incap.1q40, because I forgot to set this up. IP address 172.31.40.1. And you know what? I just realized the IP address on the sub interface for VLAN 30 is wrong. So we're going to have to fix that. So 172.31.40.1, 255, because this is going to be our, I looked down thinking that we were done. This is our /26 here. And of course, so let's get into Gigabit Ethernet 00.30, and let's fix our IP address 172.31.30.1, and this is a /25, 255, 128. Now we can go into Gigabit Ethernet 00.40, and I can pull that command right back up, and we get the right values in there. Now we are at 46%. All right, so now when I say do show run, you can see that all of those sub interfaces are up, and I am just doing a quick double check here to save us some troubleshooting down the road. Everything looks good. All right. And I'm assuming again that we've got a trunk link configured. Yeah. So I can't get into switch 1. The activity has it locked. So we will, well, that's interesting. All right. So it's going to let me into switch 1 after telling me I can't get into switch 1. So let's say show interface trunk. All right. Fantastic. And gig 01 is in fact a trunk link. So we're good to go, right? And you can see that the VLANs are 10, 20, 30, 40, and VLAN 1. So we'll get rid of switch 1. All right, so router 1, we're going to configure it to act as a DHCP server for the VLANs attached to switch 2. And we've got those VLANs here, and here are the network statements. Now you'll notice, I'm not sure if they're trying to be tricky down here, right? By giving you the 27 and then thinking that maybe you're going to have to sit there and figure out, all right, well, if it's /27, what would that be? All right, 255, 255. Well, you can just look right up here, right? So there is your dotted decimal notation version of the subnet mask. So now let's dive in to router 1 in the DHCP configuration component. But first, what we're going to do is we're going to save our config here just to make sure that we don't lose everything we've done so far. So I do a write mem, which saves our config. And so now let's configure our router 1 to act as a DHCP server for the VLANs attached to switch 2. We're going to create a DHCP pool, and the pool name is provided. And it is case sensitive. And believe me, make sure you match the case exactly. We're going to assign the appropriate addresses to each pool. Let's see if they've got an excluded. There it is. So Before I go into the DHCP configuration stanza, you can see right down here, the very last thing that it tells you is prevent the first 10 addresses from each pool from being distributed to end devices. So let's take care of that first. IP DHCP excluded address. And so the first 10 addresses are going to be from .1 to .10, and we'll see if that is the range they're looking for. .31.10.1 to 172.31.10.10. Now, let's watch our completion percentage down there. And yep, we picked up 2 points for that. So now we know what we can do is hit the up arrow, change the third octet because the first 10 addresses are the same. And we just switch it so that it matches the correct VLAN, right? And then we'll come and change this to 30. And you could watch your completion percentage as you're doing this to make sure that you're not missing anything. Whoops, and 40 and 40. Now, quick note. You'll notice that we're getting points for including the default gateway address, which is what those addresses on the interfaces on router 1 are. That's their purpose. They're our default gateway addresses for the PCs, right? And they have us include that in the IP DHCP excluded address pool. The question to you is, do you have to do that? Is that required? If I started with .2 for all of these first statements here, would DHCP offer up the default gateway address because it's not in the excluded address list? And the answer is no. Cisco iOS is smart enough to know that if that interface is configured and we are setting it up to be a member that would fall into a network statement in our DHCP pool configuration, do not give that address out. And that's iOS sort of protecting you from hurting yourself, right? Now, is it a bad idea to put it in here? No, right? This is not hurting anything. And this might be a little bit easier for somebody who's following you to look at and say, oh, okay, good. Well, they covered the default gateway address. Maybe they don't know that iOS is not going to lease out the default gateway address because it falls into a pool range for a DHCP pool, right? So if they don't know that, this is sort of like, reassuring, oh, okay, we've got that covered. So does it have to be in there? In the packet tracer activity, yes, because that's how we're getting the points. But in the real world, no, you don't need to include the default gateway address if it's a member of a DHCP pool, right? Now, are there use cases where you would do something like this? And the answer is yes. And like I said, the most obvious one would be for readability, to be able to look at this and say, oh, okay, cool, that's excluded, so we're not going to give that address out. Maybe somebody doesn't know. All right, let's do our DHCP pools here. So again, we're going to say IP DHCP pool. We want to make sure we get our pool names correct. So VLAN _10. Now, you'll notice we've got some options to choose from here. One of the questions that commonly comes up from learners is, what do I have to configure? Does it have to have a DNS server? Does it have to have a domain name? Does it have to have options? And the answer is no. There are only 2 configuration settings that are required, and that is the network and the default router. Those are the 2 settings that are required. All right, so we're going to create a DHCP pool for each VLAN as shown. Names are case sensitive. So let's do it. We'll do it in order, right? So I'll say network is going to be 172.31.10, excuse me, .0, and then our dotted decimal notation subnet mask is provided for us right up there in the addressing table at the top. So that is the network statement for the first address. Now, what about our default router? What's the default gateway going to be for the PCs receiving this DHCP information? Well, we already know 172.31.10.1. And that's it. Right there, I could stop and we're good. It's going to work. However, the activity says, assign the appropriate addresses to each pool, configure DHCP to provide default gateway addresses, configure the DNS server. And you can see that DNS server way out there, 209.165.201.14. So we've got the DNS server created. And what if you want them to have a domain name? Hey, why not? It's not going to, hopefully this isn't going to break the activity. I'll just say domain name CCIE because that's where you are headed.com. So that's going to be our domain name. And again, it's going to be wash, rinse, repeat for the other IP DHCP pool VLAN _20. We're going to come in network 172.31.20.0. We've got our dot decimal notation for a /28 up top. I saw 24 and I said 24, so 240. So it's a /28. And then let's get our default router in here, 172.31.20.1. Let's get our DNS server. In fact, the DNS server, I could just hit the up arrow because the DNS server is the same for all of these pools. And then the domain name is the same too. So then let's say IP DHCP pool VLAN _30. And let's not forget the VLAN 40 again here. So network 172.31.30.0, 255.128. Our default router 172.31.30.1. And then again, I can just quickly pull up the domain name and quickly pull up the DNS server because those values are universal. IP DHCP pool VLAN _40. And you can see the points are quickly adding up here. Network 172.31.40.0. Whoops, 255.192. I'm just double checking to make sure I didn't do that on VLAN 30. And then our default router is 172.31.40.1. And then the DNS server and the domain name, again, just kind of add-ons that we're putting in there, are added on. So everything looks good. Configure router 1 as a DHCP client so that it receives an IP address from the ISP. Well, how would we do that? Well, ironically, it's as simple as going into interface gigabit Ethernet 01 saying, and actually before we say no shut, we just simply say IP address. Now, typically you would come in here and you're going to do 209, 165, whatever, but let's do a question mark. I can just simply say IP address DHCP, and that's it. Right now, it's not going to get the address because the port is shut down. And we should see a message that comes to our screen. Let's save the config in between here. We should see a message that comes to the screen that tells us that it has received. And again, we've got this orange dot here. So I'm not going to do the fast forward arrow. Let's come down. Let's just check here. So configure R1 as a DHCP client so that it receives an IP address. We've got that. Verify each PC has an address assigned from the correct DHCP pool. All right, well, let's go ahead and click in here. VLAN 10. And let's see, is it set? So you can see that everything is set for static. So let's click DHCP, and there you go, 172.31.10.11. And let's test that. Let's see, can I ping 209.165.201.10? So right now it says destination host unreachable. And why is that? We come back to the PC here. Let's take a look at the config. What is the default gateway information here? So it shows 172.31.10.1. So that's good, right? So that looks good to me. Why is it that we can't, or we're getting that destination host unreachable? Well, if we take a look, who's responding saying they don't know how to get to that address? Well, it just so happens that it's the default router. It's router 1 that doesn't know how to get to that address. Now, I'm looking here and I don't see, and let's see what and there we go. So we've got the IP address. However, let's take a look at our routing table here. So there is a static default. So maybe it just took a second. Let's see if we run this again. If we get that destination host, and maybe I ran it a little too soon. Excuse me, I thought that had changed. So yeah, now we're going to request timeout. We've got an ARP, and we should have success after this because we've got that default static out. So the traffic should be coming back to us. And it looks like, there we go. All right, well, boy, that took a while. Patience with packet tracer is sometimes a good thing. And as you can see right there, it works. Let's come to PC2. Let's go here. Let's do DHCP. Do we get a 172.31.20? We do. and we get the correct default gateway. So let's go ahead and say ping, and let's ping the DHCP server 209.165.201. Let's do the web server first. That's Cisco PKA, and then we'll do the DNS server. And we'll give it a second here. And there we go. So if we can ping 10, we should be able to ping the 14. We'll give it a second. And it'll be on PC 2, where we're going to check to see if DNS is functioning. Does DNS do what it's supposed to do? So I've got connectivity, I've got reachability. Let's pull the web browser up here, and let's throw in www.cisco.pka. Boom, take a look at that. So we've got DNS working as it's supposed to because it translated the URL, host name, or the fully qualified URL that we had in here, www.cisco.pka, resolved it to the IP address, and then took us out to that website. Let's come here to PC3. Let's go in here and say DHCP. There's all of my addressing information. Everything looks great. Let's double check here. Can I ping out to 209.165.201.10? While that's waiting, we'll come to PC4 and we'll click DHCP. And we should get some DHCP information in here for VLAN 40. We did not get DHCP information for VLAN 40. And the reason for that is, let's take a look at 20 is in VLAN 40. So it's in the right VLAN. So this is interesting. We got a little troubleshooting here. So it's in the right VLAN from a switch perspective. Let's double check that. Let's go ahead and get in here and let's say show run. And we're going to take a look at Fast Ethernet 020. And you can see switch port mode access, port fast BPD guard. So everything looks good from the port configuration perspective. Let's say show VLAN brief. And you can see that Fast Ethernet 20 is in the right VLAN. And we had some challenges because I forgot to do some work on the router here on the sub interface. Let's say show IP interface brief. And there is our sub interface. Let's say show run. And let's make sure, did I do a DHCP pool? IP DHCP pool. Aha! So where was the mistake? That's the mistake, the typo, which I'm famous for. So let's sort that out. Excuse me. So we'll go into global config, interface gigabit Ethernet 00.40, or I'm sorry, the DHCP pool is where we're headed. So we're going to say IP DHCP pool VLAN underscore 40, and it's going to be IP address 172.31, not 41, but 40.0. 255.192. Oops, sorry, network. What am I thinking here? For some reason, I was twice thinking, yeah, I'm going to go into the router interface and we're going to fix that. So it's the network statement that we're fixing here in the DHCP pool. And you can see we even picked up a point for that, meaning, and let's save our config just in case, that if I come back over here, if I was to go to static and then swing back and say DHCP, we should pick up all of our addressing information, and we do, and you'll notice that we've gone to 100% here. So, but on router 1, what does our DHCP binding table look like? We left off right here. We've got 100%. Everything looks good. But we're back on router 1 because let's take a look at show IP DHCP binding. Let's look at some validation commands. So now we see that we've got IP addresses that have been leased out. It shows you the lease. It shows you the leasee's hardware MAC address, those 48 bits that are globally unique. And the lease expiration is just blanked out, and the type is automatic. So this shows me the bindings that are out there. All right, so that is going to do it for this introductory packet tracer activity 1.2.1 DHCP for IPv4 and routing between VLANs. All right, thank you guys so much for watching. Hopefully this video has cleared up any misconceptions or confusion you might have had. And as I always like to say, I hope to see you in the next video.